Right, so Fitts law was movement time can be predicted by certain constants, and this log to the base of 2 to a over w. So this a and b is obtained by experiment results, so we will focus on this value for now, and this value is also known as index of difficulty. And what it means by this, well, the difficulty will be increased proportionally with the amplitude, and the index of difficulty is inversely related to width of the target. So for example, which is difficult, this one or that one? The farther it is away, it's more difficult. The closer it is, the targets, it is easier. How about the widths? Which one is easier? You'll say the top one, because the widths are bigger. So the difficult one is inversely related to the target widths. And this is that expression, index of difficulty. Well, why is there 2? It is simply because if we set one target, let's say this is the first target and this is the second target, in order to hit the first target again, you have to travel back and forth twice. So that's put into the equation 2a. You need to not only move once, but back again to hit one target. So this index of difficulty is predicting the movement time. In other words, if we have same index of difficulty, we will have the same movement time. This is the example of that case, but the letter is so small, so I'll just use this one. So for our case, the first example was 4 cm amplitude and 2 cm target width. So index of difficulty by definition will be 2a, so 2 multiplied by a, 4, divided by target width 2, and to the log of base of 2. So let's have a look in the Excel file. The number I put will be log of base 2 is 4. Oh, so 2 is the index of difficulty for this case. What about, let's compare with the second one. So this example, amplitude was 10 centimeters apart, and the target width is the same, 2 centimeters. So 2 multiplied by, well, index of difficulty 2 multiplied by amplitude, which is 10 centimeters, and divided by target width, which is 2, and log to the base of 2 equals, let's have a look again, log of base 2, well, let's, no, okay. Oh, about 3.3, back again. So this one was 3.3. So you can see, well, 3.3 is bigger than 2, which means it will take more movement, greater movement time. How about this one? The third example. This case, the movement amplitude was 4 centimeters apart, and the target width is half the size, so 1 centimeter. So, well, 2 multiplied by amplitude, which is 4 centimeters, divided by target width, and log to the base of 2 equals, let's do the Excel again. This case is 8. Right, so it's 3. So index of difficulty for this is 3. So actually this one will take less time than this one because the index of difficulty is less than 3.3 for this case. Our last example, let's have a look. So 2 centimeters the amplitude and 1 centimeter the target width. So what was it again? 2 multiplied by target amplitude divided by target width and log of base 2. And this is actually the same with the first example, because it's log of base 2 of 4. So the index of difficulty is 2 for this case, which means if we compare those two, it will have exactly the same movement time. That's how the Fitts law predicts the outcome movement time.